Morning, everyone. Today we shall be looking at the important concepts in organic chemistry. Organic chemistry is the chemistry of carbon together with other elements like hydrogen, nitrogen, oxygen, sulfur, and phosphorus. We are going to look at the definition of organic chemistry, properties of organic compounds. Okay, we are going to look at some terms in organic chemistry like hybridization. We define homologous series. We also go and we will also further look at functional groups and alkyl groups, and we also divide organic compound into two: saturated and unsaturated hydrocarbon, as we further explained in the below. Look at the organic chemistry proper. So, what are organic chemistry? They are originally meant the chemistry of compounds obtainable from plant and animal origin. So, organic chemistry are compounds that are obtained from plant and animal origin. They are effectively defined as the chemistry of carbon together with a few other elements. So, chemistry of carbon together with a few other elements like hydrogen, nitrogen, oxygen, sulfur are referred to as organic chemistry. So, what are the uses of organic compounds? Why are they necessary? Why are we paying more attention to these organic compounds? So, the use of organic compounds are innumerable. Some are eaten as food, others are worn as clothing. They include the wonder drugs, the most deadly poison, and the most effective fertilizer. So they are consumed as food, clothing, production of clothes, production of drugs, poison, and fertilizer. So these are materials that can be gotten from organic compounds. So after that, what are the characteristics of organic compounds? Okay, organic compounds in nature they are covalent. What are covalent? Covalent are molecules that involve the share of electron pair. So organic compounds are essentially covalent, and they have the characteristics or attributes of covalent compounds. They are mostly non-polar and dissolve in non-polar organic solvent. They are not polar, they are non-polar. So they only dissolve in non-polar solvent like ethanol, benzene, ether, and so on and so forth. Most of them are insoluble in water. So they have low melting and boiling point. So they evaporate faster. They are thermally unstable. They are flammable. The organic reaction tends to be slower than the one you obtain in inorganic reaction. That is the most organic reaction. We tend to heat them. You apply heat or in the presence of what? Catalyst, because they are much slower. So, having known the characteristics of organic compounds, we are now going to look at terms that we use in organic chemistry. Now, the first one is hybridization of orbitals. What is the meaning of that? Hybridization is the combination or mixing of a given number of orbitals in an atom to produce the same number of new orbitals that are different in shape and better disposed for chemical bonding. The major three hybridizations we have in organic chemistry are sp3, sp2, and sp. sp3 they are meant for alkane, single bond. sp2 for alkene, and sp they are for alkyne, triple bond. So we look at homologous series. There are many different organic compounds, and it is very difficult for chemists to start studying them one after other. So what they now did is that to put this compound into family. Anyone that look similar, they put them under family, and that's what we mean by homologous series. What is the definition? A homologous series is a family of organic compounds which follows a regular structural pattern in which each successive member differs in its molecular formula by a CH2 group. So each member of a family, they differ in their molecular formula by CH2 group. The one higher will be differ from the preceding one by CH2 group. And the simplest homologous series that we can have is alkane. You have many homologous series. You have alkane, alkane, alkyne, alkanol, alkanoic acid, benzene. We have ester, we have ketone, we have alkana, we have aldehyde. So we have many homologous series, but the simplest one is alkane. So the general molecular formula of alkanes are CnH2n plus 2. Hence start from is the whole number that start from 1. So other homologous series include alkene. The whole molecular formula is CnH2n. Alkyne is CnH2n minus 2. The alkanols and the carboxylic acid with their respective general molecular formula. So, having understood the definition of homologous series and some examples, what are their characteristics? Why will ask you, define homologous series, state characteristics of homologous series. So the characteristics of homologous series are, they have the same general molecular formula that you have seen. For alkane, their general molecular formula is CnH2n plus 2. For alkene, it is CnH2n, and so on and so forth. So most of these homologous series of each family have the same general molecular formula. The difference between two groups or two selective homologue is CH2 group. They differ, two homologue, they differ in CH2 group, and their physical properties also varies. And the number of carbon atoms per molecule increases. They also have similar chemical properties. Their chemical properties is similar. They have similar method of preparation. These are characteristics of homologous series. So, we then look at a particular group that is also very important before we come properly to alkane. These are alkyl groups. What are alkyl groups? The general alkyl groups includes all groups derived from the alkane by the loss of the hydrogen atom. If we remove one hydrogen atom from alkane, what is left is alkyl group. The general formula for alkane is CnH2n plus 2. For alkene, one hydrogen will be lost. You now have CnH2n plus 1. They are named after alkane by replacing ANE with YL, and they have general symbol half. We represent half by alkene. Okay, so let's see an example of alkene. So we have methane from alkane. So methane, the formula is CH3. If there to be alkane, to be CH4. So when we remove one hydrogen from alkane, to be what? CH3. Ethane, when carbon is 2. Ethene, C2H5. Propane, and so on and so forth. These are examples of alkene that were derived from alkane by the loss of the hydrogen atoms. So now look at another group that is very essential in organic chemistry. We call them functional groups. A functional group is an atom, a radical, a group of atoms, or a bond common to a homologous series and which determines the chemical properties of the series. That is the definition of homologous functional groups. Okay, so these are different families and they are functional groups. Why do we ask you, what is the functional group of alkanol? What is the functional group of carboxylic acid? Okay, so you must know the organic compound or each homologous series with their functional group. It is the functional group that we use to recognize them. For instance, alkanes are always single bonds. We have one bond. Alkenes are double bond. Alkynes are triple bond. Alloalkanes, those ones that have halogens, we call them alloalkane. They have H. H can stand for fluorine, chlorine, bromine, iodine. Okay, so we have alkanols, OH, ether, OR, alkanas, CHO, alkanol, CO, carboxylic acid, COOH, ester, COR, primary amine, NH2, and so on and so forth. These are functional groups that most organic compounds are associated with. So, what are the effects of functional group and alkyl groups? The functional group is the one that determines the chemical properties of homologous series. Okay, while the alkyl group determines the physical properties of a compound. So, organic compounds are further divided into two. Either they are saturated or unsaturated. This division is based on the number of bonds that they have. Saturated compounds contain atoms joined only by a single covalent bond. So saturated compounds have only one bond, a single bond. And examples are the alkanes. Alkanes are saturated compounds. So these are examples of saturated compounds for alkanes. Okay. So and so we have unsaturated compounds. They contain two or triple covalent bonds. And the example of some that are unsaturated are the alkene and alkyne.